Welcome to Chapter 6, Interest Rates and Bond Valuations. It is advisable that all students go to Chapter Resources in Pearson, click on it, scroll down to Chapter 6, click on Videos, and review the videos on interest rate and bond valuations 6.1, 6.3, 6.10, and 6.12 examples. Additionally, you want to finish and complete any type of reading material in the book related to calculations. Okay, let's start off with Chapter 6, Exercise 1. The nominal risk-free rate on T-bills is 1.23%. If the real rate of interest is 0.8%, what is the expected inflation rate? So we set R equals the nominal interest rate, R star equals the real interest rate, and I is the expected inflation rate. The formula to use to solve for the expected inflation rate is 1 plus the nominal interest rate multiplied by 1 plus the real interest rate minus 1. And if we plug in the values for the nominal interest rate of 0.0123 or 1.23% times 1 plus the real rate of interest at 0.8% or 0.008 minus 1, we come up with the value of 0.004269, or if we round it off to the nearest thousands, it'd be 0.043%. Exercise 4. Assume that the rate of inflation expected over the coming year is 3.3%. Explain how a one-year T-bill could earn a negative real rate of return over the next year. How could it have a zero real rate of return? What minimal rate of return must the T-bill earn to meet your requirement of a 2% real rate of return? A T-bill will yield a negative real rate return if its nominal return falls below the inflation rate. More precisely, if we let R star be the real interest rate and R the nominal interest rate and I the expected inflation rate, we can calculate as follows. Setting the equation to find the nominal interest rate will equal 1 plus the real interest rate times 1 plus the expected inflation rate minus 1. In solving the numerical problem, we end up with a nominal interest rate of 3.3%. In calculating the nominal interest rate, we have a real rate of return of 2% and an expected inflation rate of 3.3%. In substituting R star and I, we derive a nominal interest rate of 5.37%. We conclude that if the nominal rate on a T-bill falls below 3.3%, the real return will be negative. To earn a 2% real return, the nominal rate R must be 5.37%. Exercise 5. Calculate the risk premium for each of the following rating classes of long-term securities. Assume that the yield to maturity for comparable treasuries is 4.51%. If we set RJ as the nominal rate and RF as the risk-free rate and RP as the risk premium, our formula is as follows. RJ equals RF plus RP. But they're asking us in this question to solve for the risk premium, or RP. Therefore, we must rearrange our formula to our nominal rate, RJ, minus the risk-free rate will equal the risk premium. In doing so, as example number 1, and you can follow through and calculate the other risk premiums, but I'll do the AAA security. The nominal interest rate will set at 5.12%. Our risk-free rate was 4.51% to yield a risk premium of 0.61%. Exercise 6. You have two assets and must calculate their values today based on their payment streams and required return. Asset 1 has a required return of 9% and will produce a stream of $300 starting in 1 year and continuing indefinitely. This is an example of a perpetuity we studied in the last chapter. Asset 2 has a required return of 7% and will produce a cash flow in the first year of $1,400, in the second year of $1,300, in the third year of $850. Let's find the present value of both assets. Using the perpetuity formula of present value equals cash flow divided by the required rate of return, our present value equals $300 divided by 9%, or 0.09, equals a present value of $3,333.33. In Asset 2, we're trying to calculate the present value of three different types of cash flows. The present value of $1,400 is calculated by the future value of 14 divided by 1.7, which is the required rate of return to 1 year. The second cash flow is we have to discount it, we call it, the present value of $1,300, which is actually the future value of $1,300, but taking the present value, we divide it by 1.07 to the second power. And our last cash flow at $850 is we have to calculate the present value of 850. And remember, the 850 is actually the future value, but we have to calculate it at its present value. And it's 1.07 to the third year. And if you can recall the formula for present value, the present value equals the future value of a lump sum divided by 1 plus the discount rate to the number of periods. So in order to calculate asset 2, we have to utilize the formula and add each year's present value which will derive us a final value of $3,137.73. Exercise number 7. A bond with 5 years to maturity and a coupon rate of 6% has a par or face value of $20,000. Interest on this bond is paid annually. The required rate of return of the bond is 8%, or another way of looking at it is the market rate of the bond is 8%. They want us to calculate what is the price of the bond. Now, the present value of a bond is calculated by discounting the coupon payments, which is a cash flow. The cash flow equals 6% times the face value of $20,000, which equals $1,200 a year. So we take the coupon rate times the face value of the bond in order to derive the interest rate. The second component of the present value of a bond is taking the face value of the bond and utilizing the market interest rate or the required rate and discounting it back. In this case, the present value of bond can be expressed by the formula below with a 5-year to maturity. So the 5 years is when the bond matures. And we can see below the present value of bond is broken into 2 parts. The present value of the stream of interest payments plus the present value of the redemption value. And the redemption value is just the face value that is paid off at the end of 5 years from whoever has issued the bonds. To find the present value of the bonds, we take first the present value of the stream of interest payments, which is this formula right in here. Our cash flow, we know, is $1,200. Our required rate of return is 8%. And we multiply that by 1 minus 1 over 1 plus the market or required rate of return to the number of years of maturity, which is 5. The second part of our present value bonds are the M is the face value of the bonds divided by 1 plus the market rate or the required rate of return to the number of years of maturity, which is 5. If we do the calculation, we end up with a present value of the bond being $18,402.91. Problem 11. Bond prices and yields. Assume that the management corporation has a $1,000 par value bond with a coupon rate of 5.7%. and it will mature on May 15th, 2027. Has a current price quote of 97.708 and has a yield to maturity of 6.034%. So they're going to ask us some questions. Number one, what was the dollar price of the bond? When a bond is quoted at 97.708, it means that it's 97% of the face value of the bond. Bonds are sold in increments of 1,000. So each bond, if we multiply 1,000 by its percentage of 0.97708, we derive an answer for the dollar price of the bond being $977.08. To calculate the bond's current yield, we take the coupon rate, multiply by the face value of the bond, divided by our bond cost. In this case, our coupon rate is 5.7%. We multiply it by 1,000, divided by, we paid the bond for the bond, $977.08, and hence the bond current yield is 5.83%. Is the bond selling at a par, at a discount, or at a premium, and why? I encourage you to make sure you review the videos in understanding the par value, a discount, or a premium on a bond. But this particular bond is selling at a discount because its coupon rate, 5.7%, is below the current market yield on bonds of equivalent risk. In other words, today's market price has bonds at 6.034%. Maybe a few years back, the bond that someone purchased is at 5.7%. Now, because today's market value of bonds are 6.034%, the percentage is greater than what somebody may have paid for a bond whose market price at that time, or market rate, was at par, or 5.7%. You can think of interest on bonds like mortgage interest rates, and they go up and they go down with time. Please review, again, the chapter concepts regarding how to calculate a bond at a discount, premium, or at par. Lastly, the yield to maturity is greater than the current yield because yield to maturity includes 22.92 in price appreciation from now to maturity on May 15th, 2027. Okay, problem 15. Basic bond valuation. Complex Systems has an outstanding issue of $1,000 par value bonds with a 12% coupon rate. The issue pays interest annually and has 16 years remaining to its maturity date. So let's start off with A. If the bond of similar risk are currently earning 10%, or the market return today is 10% rate of return, how much should the complex system bond sell for today? In taking the present value of the bond formula, we have the stream of cash flows to the left, and to the right we have the face value of the bonds divided by the rate of return in the market. So in order to calculate the present value of the bond, we take the cash flow, we take 12% times $1,000 and get 120. That's the cash flow. Divided by the market rate, multiplied by 1 minus 1 over 1 plus the market rate or required rate of return to the number of years, which is 16. We add that to the face value of the bond, M, which is $1,000. Again, we use the market rate of 10%, and then we put it to the 16th power, which is the number of years. So our present value of the bond is $1,156.47. What that means is that a bond today is paying 10%. I hold a bond that's paying 12%. What's valued more, a bond at 10% or a bond at 12%? Well, my bond at 12% pays more interest and therefore is valued higher. And that is why this bond is selling at a premium above par, above the $1,000. B. Describe the two possible reasons why the rate on similar risk bonds is below the coupon rate on complex system bonds. Complex system bonds sell at a premium, meaning the required return has fallen since the issuance. In other words, the market price or interest rates have fallen. One possible reason is decline in the risk-free rate because of changes in the macroeconomic conditions. Another is a decline in the default risk because the firm's financial condition has improved. C. If the required return were at 12% instead of 10%, what would the current value of the complex bonds be? The answer may be found in Excel using the present value function, setting R to 12, N to 16, the payment at 120, and the future value or the face value of the bond at $1,000. You can also use the formula represented previously. In this case, instead of setting the rate of return on the market to 10%, we would put it at 12%. And if we put it at 12%, we will end up at a present value of $1,000 because the market rate of the bond equals the coupon rate of the bond. Problem 18. Bond value in time. Constant required returns. Pecos Manufacturing has just issued a 15-year 12% coupon rate $1,000 par bond that pays interest annually. The required rate of return is 14%, and the company is certain that it will remain at 14% until the bond matures. Assuming that the required return does not remain at 14% until maturity, find the bond value at different points of time. 1, 2, 3, 4, and 5. So they have 15-year, 12-year, 9-year, 6 years, and 1 year. Now you can use the formula, the PV formula, to solve it that we've been using before. Or, if you want a quicker way of doing it, you can open up an Excel spreadsheet, pick a cell, and enter the values. And the values would be, you have to put equals in a cell, PV, parentheses, the values be the required return, that means the market rate of return, years maturity, the coupon rate, and the face value or par value of the bond. Plugging your equation into Excel is much quicker. In this case, I'm going to do 1 year to maturity. So in a cell, all you got to do is equals PV parentheses 0.14, which is the interest rate, required return, comma, the number of years to maturity, which is 1, the coupon rate, which is 12% times $1,000, 12 times 1,000, 120, and the par value of the bond, which is the face value. If you plug that in, you will end up with faster answers than if you calculate using the long way. If we were to use Excel, you can see we can calculate the years to maturity 1, 3, 6, 9, 12, and 15 very rapidly and derive the bond values. Year 1 to maturity would be $982.46. Then year 15 would be $877.16. If you're still having trouble with using Excel to find the present value of a bond, I would refer you to utilizing YouTube, which has a lot of videos that can help you use Excel to calculate the present value of a bond. As we can see from the price of the bond and the yield to maturity, when the required return differs from the coupon rate and remains constant to maturity, bond values will approach par value as time to maturity declines. And you can see this curve, right, reaching par value of $1,000 as the maturity declines, the years to maturity declines. Problem 21. Yield to maturity. The Salem Company bond currently sells for $867.59, has a 6% coupon rate, and a $1,000 par value. It pays interest annually and has 15 years to maturity. Calculate the yield to maturity on the bond. Explain the relationship that exists between the coupon rate and yield to maturity and par value and market value of bond. It is advisable to go to Excel to calculate the yield to maturity. The yield to maturity equals the rate, and that's what you're going to put in a cell, equal rate, parentheses, N is the number of years to maturity, C is the coupon rate, minus the bond price, entered as a negative number. Okay, so you want to put a minus there for a negative number, and M, the par value of 1,000. So we have 15 years, 60 is the coupon rate, 6% of 1,000, minus the current bond selling price, comma, times the bond price at par, what the issuer has to pay the bondholder when the bond matures, which is $1,000. If we calculate all that, we end up with 7.50%. Explain the relationship that exists between the coupon rate and the yield to maturity and the par value and the market value of the bond. Note in Part A, the bond sells at a discount rate of $867.59 from par. The yield to maturity is 7.5% and exceeds the coupon rate of 6%. The required return has risen since the bond was issued. For this bond to offer the same return available on bonds of similar risk now, the price must be until the year to maturity equals the current required return. Similarly, if the bond sells at a premium, year to maturity must be less than the coupon rate. Required return has fallen since the bond was issued. So bond traders raced to get the attractive coupon rate, pushing up the bond price until the year to maturity equaled the current required return. Cut. Explain the relationship that exists between the coupon rate and the yield to maturity and the par value and the market value of the bonds. Note in Part A, the bond sells at a discount, $867.59 from the par value of $1,000. And the yield to maturity is 7.5% and exceeds the coupon rate of 6%. The required return has risen since the bond was issued. For this bond to offer the same return available on bonds of similar risk now, prices must fall until the yield to maturity equals the current required return. Likewise, if the bond sells at a premium, yield to maturity must be less than the coupon rate. Required return has fallen since the bond was issued. So bond traders race to get the attractive coupon rate, pushing up the bond price until the yield to maturity equaled the current required return. And that is it for our problems for this week.